The ability of humans to conquer the skies through aviation is one of the most remarkable feats in the history of scientific and technological advancement. Air travel has revolutionized the way we connect with the world, enabling us to traverse vast distances in a matter of hours. At the heart of this marvel of engineering lies the profound understanding of aerodynamics, a branch of physics that governs the behavior of air around objects in motion. In this video, we delve deep into the principles that enable planes to fly, from the basics of lift and thrust to the intricate mechanisms that keep aircraft stable and controllable. The fundamental forces that enable flight are lift, weight, gravity, thrust, and drag. To overcome gravity and stay aloft, an aircraft must generate enough lift to counteract its weight while maintaining sufficient thrust to overcome drag. Lift. Lift is the force that pushes an aircraft upward against the pull of gravity. It is generated primarily by the wings through a phenomenon known as Bernoulli's principle. As air flows over the curved upper surface of an aircraft's wing, it travels faster and creates an area of lower pressure compared to the slower-moving air beneath the wing. This pressure difference results in an upward force, lifting the aircraft into the air. Weight. Weight is the force exerted by gravity, pulling the aircraft downward. To achieve flight, the lift generated must be greater than the weight of the aircraft. Thrust. Thrust is the forward force produced by the aircraft's engines. It propels the aircraft through the air, overcoming the resistance of drag. Jet engines, propellers, and even rocket engines are all mechanisms used to generate thrust. Drag. Drag is the resistance the aircraft encounters as it moves through the air. It is caused by friction and the disruption of airflow around the aircraft's surfaces. Minimizing drag is crucial to ensure efficient and economical flight. The shape of an aircraft's wings plays a critical role in generating lift and controlling its flight. The cross-sectional shape of a wing, called an airfoil, is carefully designed to optimize lift and minimize drag. The camber, or curvature, of the airfoil contributes to the pressure difference that generates lift according to Bernoulli's principle. Additionally, the angle of attack, the angle between the wing's chord line and the oncoming air, impacts the lift and drag characteristics of the aircraft. Aircraft are equipped with control surfaces that enable pilots to maneuver and maintain stability during flight. Ailerons. Ailerons are movable surfaces located on the trailing edge of the wings. By deflecting ailerons upward on one wing and downward on the other, the pilot can roll the aircraft to the left or right. Elevator. The elevator is usually located on the horizontal tail surface and controls the aircraft's pitch, allowing it to climb or descend. When the elevator is deflected upward, the aircraft's nose pitches up, and when deflected downward, the nose pitches down. Rudder. The rudder is positioned on the vertical tail fin and controls yaw, the rotation of the aircraft around its vertical axis. By deflecting the rudder left or right, the pilot can make the aircraft turn in the desired direction. Flaps. Flaps are located on the trailing edge of the wings and can be extended or retracted. They increase lift and drag during takeoff and landing, allowing for safer and slower flight at these critical stages. Flight can be divided into several stages: takeoff, climb, cruise, descent, and landing. Each stage involves specific adjustments to the aircraft's control surfaces, engine thrust, and speed to ensure a smooth and safe journey. Takeoff. During takeoff, the aircraft accelerates along the runway, with the pilot gradually increasing the angle of attack to generate sufficient lift. Once the necessary lift is achieved, the aircraft becomes airborne. Climb. In the climb phase, the aircraft gains altitude by maintaining a specific angle of attack and adjusting engine thrust. The pilot uses the elevator to control the rate of climb. Cruise. During cruise, the aircraft maintains a steady altitude and speed, with lift balanced against weight and thrust balanced against drag. This phase is characterized by efficient and relatively level flight. Descent. The descent phase involves reducing altitude while maintaining controlled forward motion. The pilot adjusts the aircraft's pitch, thrust, and descent rate to ensure a gradual and safe descent. Landing. Landing requires precise control as the aircraft descends and touches down on the runway. Flaps are often extended, and the pilot uses a combination of throttle, elevator, and aileron inputs to execute a smooth landing. The ability of airplanes to fly is a complex interplay of physics, engineering, and skilled piloting. From the principles of lift and thrust to the intricate mechanisms of control surfaces and stability, aviation embodies centuries of scientific understanding and technological innovation. The remarkable feat of human flight continues to captivate our imaginations and inspire further advancements in aeronautics, opening up new horizons and connecting the world in unprecedented ways.